Okay, hello math students. At this time, we have finished everything that we wanted to accomplish in our math textbook, so I want to go on to some enrichment. This would have been to prepare you for the NWEAs. It's not a standard for 8th grade. However, I find it extremely important and should be a standard for 8th grade. So I'm putting it in now. We, of course, learned how to solve equations with a variable x. Now all we're going to do is solve an equation with the variable x with an inequality sign. Inequalities are just arrows, greater than, less than, greater than or equal to, less than or equal to. When we would graph an x equals 3, we would put just a dot on a number line. Now when you have an inequality, it's not just the number 3, it's 3 and everything larger or everything smaller. So we do something called shading. So let's go ahead and look at these slides. Solving inequalities. X is greater than 3. I have a number line. I put a circle at 3 and I shaded to the right. How did I know to do that? Here are the rules. Solid circle if you have an equal sign attached. So if there is an equal sign attached to your arrow, then you get a solid circle, just like x equals 3 would be a solid circle. I have an open circle when there is no equal sign attached. I shade to the right when it's greater than. I shade to the left when it's less than. Keep in mind that the variable, that's the x, that's the letter of the alphabet, is always on the left when you begin plotting or graphing. If you need to move the variable to the other side, then you have to flip the sign. So in this case, I have 3 minus 4 is greater than x. I want x to come first. I want it on the left. So if I want to move it to the left, I have to take the sign with me. Notice the arrow is pointing at the x. I need it to still point at the x. This is actually the same. This right here says x is less than 3 minus 4. X is less than 3 minus 4. Remember, wherever the arrow is pointing is the less than value. 2 basic rules for inequality equations, which are different than regular equalities. If you multiply or divide by a negative value, so if you multiply or divide both sides by a negative value, you must flip the sign. If you want to move the variable to the opposite side, you must also flip the sign. Here I have examples. The shaded graph region follows the direction of the arrow. X is greater than 1. Open circle at 1, shade to the right. X is less than or equal to 2. Solid circle at 2, shade to the left. The shading rule only applies when the variable comes first. So you must have the variable first. If you're taking a test and you see that the variable is on the right, you need to reverse everything. You need to move it to the left and flip the sign. And of course, they're going to put the variable on the right on a test because they want to make sure you understand how to move it and how to graph it. X is greater than 4. Open circle at 4, shade to the right. If this is the common mistake you will make, 4 is less than x. You put an open circle at 4 and you shade left because the arrow is left. The problem is x is on the right-hand side, so you cannot graph it the same. This is incorrect. You can see that the two graphs are not the same. You must move the x over, otherwise everything has to be inverse. X is greater than 4. Always say the inequality starting with the variable. So even if the variable is on the right, Start with the variable. X is greater than 4. Then you know greater than means shade right. If you want to shade with the arrow, then you must have the variable first. This is a good practice. It'll also prepare you for linear inequalities. We already did linear equations where we graphed a line. But guess what? You actually can graph an inequality. It just requires shading, but we will get to it. Now, let's do addition and subtraction with inequalities. Of course, we did all of this in Unit 1 with equalities. So Unit 1 might be a really good thing to go back and review, but for now, we're going to move forward. Solve just like an equality, but you graph it different. I'm showing you the two. If you had an equality, x plus 7 equals negative 10, you would use the inverse operation and subtract 7 from both sides. These would cancel out and you'd be left with x equals negative 17. You'd put a solid dot at negative 17 and you're done. For an inequality, I had x plus 7 is less than negative 10. Same operation. I need to remove the plus 7 because I need x to be alone. I need to isolate the variable. The inverse operation of plus 7, subtract 7 from both sides. X is less than negative 17. A negative 10 and a negative 7 combined to make negative 17. Open circle at negative 17 because there is no equal bar under the arrow. Less than, shade to the left. I need to isolate x. Add 11, it's the inverse operation, add 11 to both sides. The sign does not move. I have not multiplied or divided by a negative. I did not flip the variable. The sign stays the same. Negative 22 and a positive 11. You need to review your rules of integers. A positive and a negative is the difference between the two and use the sign of the larger digit. Less than or equal to negative 11. Solid at negative 11, shade left. Subtract 6 from both sides. I isolate the x. Negative 3 and negative 6 make a negative 9. X is greater than or equal to negative 9. Solid circle at negative 9, greater than, shade to the right. What if I go backwards and I start with a graph and I need to create the inequality? You always start with the variable. So you start with x. So you come down and you just write x. Determine, did it shade to the right or the left? It shaded to the right, greater than. Was it a solid or open circle? If it was an open circle, you're done with that step. But if it's a solid circle, you need to add the equality sign. Now determine where the circle is. It's at 1. So 1. You have now written your inequality. It's actually very easy to work backwards, easier than going forward. Example, 3 is greater than x plus 4. I need x to be isolated, so I subtract 4 from both sides, and I get a negative 1 is greater than x. But I want to move x to the left. So if I'm going to move x to the left side, I need to take that greater than sign and flip it and make it a less than sign. And I move my negative 1 to the opposite side. So my x and my negative 1 flip sides, and my sign flips. And I have x is less than negative 1. Open circle at negative 1, shade left. Important rule. If you move that variable to the opposite side, you must flip the sign to go with it. Enjoy.